I'm Ethan Harvey, and this is AP Stats Quideo number 4, basic question. The Census Bureau reports that households spend an average of 31% of their total spending on housing. A home builders association in Cleveland believes that this average is lower in their area. They interview a sample of 40 households in the Cleveland metropolitan area to learn what percent of their spending goes towards housing. Take mu to be the mean percent of spending devoted to housing among all of Cleveland's households. We wanted to test the hypothesis. So our HO is 31%. An alternative hypothesis is less than 31%. So we're just trying to see if the true proportion is less than 31%, and it tells us that the population standard deviation is 9.6%. So question A, what is the sampling distribution of the mean percent of X bar that the sampling spends on housing if the null hypothesis is true? And it tells us to sketch the density curve of the sampling distribution. And it says sketch a normal curve first, then mark the axis using what you know about locating standard deviation on a normal curve. Alright, if you come over here, I've drawn a normal curve first with our mu in the middle of 31%, and then just adding the 9.6% for the standard deviations on either side. As you can see, that gives us this. But that's not the sampling distribution. To find the sampling distribution, we need to find this standard deviation, which is easily found by taking the regular standard deviation and dividing it by the square root of n, which is the number of subjects, which we can see over here is 40. So when we get this, we get that the standard deviation for the sampling distribution is 1.52. So over here I've resketched this, but instead of adding the 9.6, I've added 1.52 and gone out 3 standard deviations. And over here, also we should check our assumptions, just to make sure this is a valid study. So big enough, we take our n and multiply it by each proportion, so the 31% for the total spending, and that gives us 12.4, which is above 10, so we're good here. Do the same for the q, and we're also good here. If we're small enough, we just take the n, multiply it by 10, we get 400. So this needs to be less than the total population, and there are more than 400 households in the USA, so we're good here too. Alright. So, question B says, suppose the study finds that X bar is equal to 30.2% for the 40 households in the sample. Mark this point on the axis in your sketch. So over here I have marked 30.2 here. And it says, then suppose the study result is 27.6%. Mark this point on your sketch, and I've also marked this here. Then explain in simple language why one result is good evidence that the average Cleveland spending on the housing is less than 31%, whereas what the other result is not. Alright, so the first result that it gives us, the 30.2%, is good evidence that our original hypothesis is true, meaning the original claim is most likely correct and that the spending is not less than 31%. This is due to the fact that you can see it's pretty close to the 31%. It's in fact less than 1 standard deviation away. So if we were to make a reasonable confidence interval, the 31% would be within its range. So the other piece of data that it gives us is 27.6, and you see this here. It is above 2 standard deviations away. So this is good evidence that our actual proportion is below 31%, because if we were to make a confidence interval for this data, 31% would most likely not be in its range, meaning that the true mean, true proportion would be lower than 31%. Alright. And for C, it's the shade the area under the curve that gives a p-value for the result of 30.2%. Note that we are looking for evidence that spending is less than the null hypothesis states. So as you can see, I have shaded all this. So we are looking for where it is, for the fact that it's less. So all of this shaded area is not good evidence that's less. We would want less area if we were looking to say that is less with the 30.2%. Okay, this is AP Stats Quideo number 4 advanced question. Pew Research in November 2011 polled a random sample of 799 U.S. teens about internet use. 49% of those teens reported that they had misrepresented their age online to gain access to websites and online services. So for A, it tells us to find the margin of error for this poll if we want a 95% confidence in our estimate of the percent of American teens who have misrepresented their age online. Alright, so to find a margin of error, we just use this formula. So plus or minus the z star and square root of pq over n. So the z star for a 95% confidence interval is 1.96, and we can just find this with our z-score chart. So we just plug in all the values. So 0.49 is the percent that it gives us, and the Q would just be 1 minus 0.49, and then over 799 as the number of subjects. And we get plus or minus 0.03466. So we can add this back to the 49% and subtract it from the 49% to get this range. So B says, explain what the margin of error means in context. Alright, so basically this margin of error is our confidence that the true proportion lies within the range that we found. So for this, we are 95% confidence that the proportion of teens who misrepresented their age online, the true proportion, is between 45.534% and 52.466%. And then C says, if we only need to be 90% confident, what margin of error will the margin of error be, larger or smaller? So we can find this just by changing this z star in our original equation. So if we go to that z-score chart, we get the z star for 95% is 1.96, but for 90% it is only 1.645. And z star is the only thing that's going to be changing in our equation. So if this becomes smaller, then the overall range will become smaller as well. So the size of the margin of error will decrease. Okay, this is AP Stats Quideo number 4, the AP question. Each person in a random sample of 1,026 adults in the United States was asked the following question. Based on what you know about the Social Security system today, what would you like Congress and the President to be doing next year? The response choices and their percentages are shown below. So we can just see this little table of their responses and the percent of people who said that. So for A, it tells us to find a 95% confidence interval for the proportion of all United States adults who would respond make some major changes to the question. So that is the 39% here. Give an interpretation of the confidence interval and give an interpretation of the confidence level. Alright, so for this, we're just going to use pants. So first we need to name our parameter. So we're just going to call x the percent of adults who would respond make some major changes. Next, we should check our assumptions to make sure this is a valid study. Big enough, take 1026 times 0.39, 400, that is bigger than 10, so it is big enough. And for the Q, we do the same thing, and it is also big enough here. And for small enough, we just take the N times 10, so that would be 10,260, and there are more than 10,260 adults in the United States of America, so we're good here too. Alright, next we'll name the test. We will be using a 1 proportion z interval, which is this formula here, and next we will apply the test. So we will just plug in all of our data, the 0.39, which we got from here, and the 95, we're making a 95% confidence interval, so the z star is 1.96. We can find this from the z-score chart, or just remember it. And then we'll also plug in our n, our q, and our p, our q, and our n. And we will find that the confidence interval is 0.39 plus or minus 0.0291, or 0.3609 to 0.4191. So basically all this is saying is that we are 95% confident that the proportion of adults who would answer the make some major changes is between 36.09% and 41.91%. So we're just saying that the true proportion, we're 95% confident it would be between these values. Basically, in other words, we're saying that if we were to run this study 100 times, that 95 of them, the 95 of the true means would be within the confidence interval, those intervals that we make. So 95% of the confidence intervals we generate will contain the true proportion. Alright, and for B, it says an advocate for leaving the system is now, as it is now, commented, based on this poll, only 39% of adults in the sample responded that they want some major changes made to the system, while 41% responded that they only want minor changes or no changes at all. Therefore, we should not change the system. Explain why this statement, while technically correct, is misleading. Alright, so first off, he's basically comparing the people who want to change the system and the people who don't. So these two want to not change the system. So 30 plus 11, that is 41%. But these two want to change the system. But he only included the make some major changes when talking about the people who wanted to change the system. He left this whole 19% of people out. So, because the advocate left all those people out of the study, it's very misleading. because technically it's correct because only 39% of adults said that they wanted some major changes, but 19% more said they wanted something more than major changes. They wanted a complete overhaul. So if he had included this, it should really look like 58% of people want to change the system and 41% of people don't.